The end user starts GravityAR, chooses between two topics related to Einstein's theory of general relativity. The application is composed of 30+ scenes in addition to 30+ cards. GravityAR is self-contained in the sense that it contains the Fourier markers so the user can print them from within the application. The end user has the capability to navigate between these scenes through a previous and a next button, in addition, to repeat the audio for any scene and at any time. By scanning a QR-based marker, general relativity models are viewed. Audio will be played, briefing the user about the models shown and the related theoretical content. The end user can also read a text on the card that contains the QR-based Fourier marker through the screen. There are pop-up questions that the end user will answer as an engaging interaction. GravityAR is built to be viewed sequentially. Therefore, the ability for the user to navigate between two topics is solely for bachelor defense purposes.
Within the space-time fabric, it is very similar. Objects seem to attract each other. It just looks like they attract each other, because they are getting closer to each other. When, in fact, all objects are simply following the curvature of the fabric. Adding a clock at each intersection of the grid offers two advantages. Firstly, time dimension is no longer ignored since it's called space-time fabric after all. Secondly, it shows that time can flow differently depending on the curvature. However, there is a disadvantage here. This representation is not simple or intuitive at all. It is very complex. We can do a trick to simplify it though. Sometimes, when a 3D shape is complicated to imagine or to study, we slice it and study a 2D version of it. Because lowering a dimension simplifies it. So, we are going to use the same trick. Instead of viewing the space-time fabric in 4 dimensions, we are going to view it in only 3 dimensions. We remove one space dimension from the total 4 dimensions that we have. After applying this trick, we are left with 3 dimensions which are 2 space dimensions plus 1 time dimension. It is the time components that explains the gravity. The apple is always in motion. Even with no initial speed, the apple is moving in time. Notice how the apple's position is changing over time. So, now, we understand that the curvature of space-time fabric bends a path to the future and to the ground. We, therefore, understand that if the apple falls, it is because the apple started with a speed through time. This is hard for humans to understand because of how we understand time. We do not experience this representation as it is, as we see the world from this astronaut's perspective. While Einstein agrees that light always takes the shortest distance, he also states that the shortest distance is never a straight line. This is because of the curvature of space-time fabric that we earlier discussed. Let's remember. Restricted to the surface of the sphere, the shortest distance is never a straight line. Wherever you traverse the surface of the sphere, you are always moving on a curve. For example, here, Astronaut X is trying to reach Astronaut Y in the shortest distance. Astronaut X just moved a curved distance. The exact same thing happens to light.